So my talk primarily focuses on forensics, but we have applications in other areas of security as well. But primarily for forensics, much of the valuable information that an investigator might want to have is currently not available. And this is partly due to the fact that the information simply isn't there, or it's not there and it's not recorded, or it could be that it has to be derived by correlation, which can be tedious and error-prone. So during this talk, I'm going to raise a question of what the desired information actually is when performing a digital investigation. And in the second part of my talk, I'm actually going to focus on two of these pieces of information, which is user influence and location information. So in the first part, I'm just going to explore a little bit of what kind of information do we actually want of a system as a forensic investigator. Then I'm going to introduce a model that uses labels to track information on a system, present some case studies about that, discuss the implementation, and then conclude and present some future work. In digital forensics, usually you're concerned with retrieving and analyzing digital evidence. And existing tools focus primarily on the actual retrieval of that information. And that is a pretty straightforward goal, because you have to see what you can get off the system, what's actually there in order to analyze it. But apparently, nobody has asked the questions, what kind of extra information would you want to have, if you could, for a forensic investigator to make your investigations more easy? So usually the information retrieved from a system is either stored on the file system metadata itself or in the logs. And given that information, you basically only have a small snapshot of the system. You cannot really determine some of the answers of questions you would like to have asked, you would like to have answered. There we go. So before I actually go into the area of what the information is that we want, here's a quick classification of the desired information that is either there or not there. So the first category is information that is available on a system and is actually recorded explicitly on non-volatile media. And an example of this would be the file access modification and change times of a file system. In the next category, we have information that is available, but it's not explicitly recorded. For example, this could be the user ID of the person who modifies a file. The system knows about it, but when actually an operation on a file is performed, this information is not recorded anymore. And the next category is information that is not available to the system, but that we can probably make available. And an example of this might be location information. Current computing systems do not really have a sense of what location is, but one can make some of that probably available. And the last category is information that we might want, but it's actually impossible to be obtained. And I'm actually going to get into that aspect a little bit later on. So what do we want as a forensic investigator? And of course, it really depends on the kind of investigation that we are doing. It could range from simply locating contraband material to a full-fledged investigation of a break-in, trying to figure out what happened. And in the most general case, we want answers to all these questions. Who did what, from where, when, how was it done, and why was it done? And I threw in the why there, but usually you have to answer all the other questions and then make a guess as to why the attacker or criminal or who knows what did his actions the way he actually did. So now I'm just going to go through most of these and give suggestions explaining why we want the information and give suggestions as to how we can rectify this. I'm not going to pretend that I'm going to solve all these things, but I'm just going to discuss what is wrong with some of the existing information and what we can do about it. So the first question is the when, and that's an easy one. Because most file systems actually carry timestamps. They're called MAC times, which stands for modify, access, and change times. And they're being stored as metadata of the file system. However, MAC times simply emerge from the need for different tools, like archiving tools, backup tools, compile tools, and all that. And actually, there's no really standard for any of those. So on different systems, you actually have different kinds of files of timestamps. For example, on Windows NT, on NTFS, you have an explicit creation time, which Linux does not have. Linux has a delete time, which Windows does not have, and so on. Plus, we have misleading names of the timestamps. Sometimes the C part of the MAC time is called a create time, but in essence, it's really a change time. It is updated when the metadata of the file actually changes, which initially is the creation time. But if you do things like change permissions on the file, then that change time is updated also. Plus, timestamps are very easily changed. There are userland tools you can do. There's a touch command which changes the access time, the change mod time, changes the change time, the C part. You can edit a file to change the modification time, and so forth. And in addition to that, only the latest operation, only the timestamp for the latest operation is kept. So everything that was before that is gone. So what can we do about the when part? First of all, you should have standard timestamps available on your system, which should include a create, a delete, an access, a modify, and the change time. Then these timestamps should not be subject to alteration from a user, which means that the system has to keep us and they can't be modified. And if you still need timestamps that the tools I mentioned, the backup tools, or whatever tools they need, then you can have extra timestamps in userland that fulfill that role. And the last point is, ideally, you want to keep timestamps for all operations that took place. Now, this can take space because many files are accessed quite frequently or other files are modified frequently. But you can categorize things. If you have files that you do not expect to be modified in a frequent manner, you can log the modification times for that, and if there is frequent activity, that should stand out. The same goes for access for certain files you don't expect to be accessed all that much. And all of that depends on the system policy. So the next category of information is the how question. So how did things happen on a system? And basically, I want to ask which programs were used to perform an action on a file. And it should make a difference whether notepad.exe was used or a program called backdoor.exe in order to create a file, for example. And these programs act on behalf of the user, and I call them controlling agents. And there can be a chain of those. So you can have a chain of programs executed and then perform an operation on a file. So for example, from the command line, you